Okay, this video is being made in order to help understand how to solve a system of equations, such as the system up here at the top, negative x plus y equals 1, and 2x plus y equals negative 2. Again, a system of equations being more than one equation. And how to find the solution to that system, the one coordinate that will make both equations true, via the substitution method. Substitution method is kind of exactly what it says. It's not really an inventive name. Our hope is to substitute into one of our two equations by taking out a variable and putting in what that variable is equal to. Now, first thing that you want to do in order to do the substitution method is come up with one equation solved for one of your two variables. So up here in these two equations, it would not be hard to solve for x, but the two y's are much easier to solve for. So the first step that I took was to take this second equation and to subtract 2x over to the right side. So the y is still on the left, negative 2 is still on the right, but this positive 2x becomes a minus 2x over on the right. Now I have an equation solved for one of my variables. I have y equal to that entire equation. So the next step, and the big step, is to remember that this y that's up here at the top, right here, is the same y, again, that was in the other equation. Lost my equation there. Which is the same y that's right here. So if y is the same in all of these places, then I should be able to take the y out of the first equation and replace it with this entire statement in the second equation. And in that case, negative x plus what used to be y, right here, negative x plus, again, what used to be y, negative 2x minus 2, or negative 2, sorry, minus 2x, is equal to 1. Again, it's just that first equation rewritten, y is removed, and negative 2 minus 2x is inserted. After that, really we just need to kind of clean it up. This set of parentheses really isn't doing anything, so if we sort of ignore those, we've got a negative x minus 2x, in which case that's negative 3x. Adding like terms. We've got a minus 2 or a plus the negative 2 going right here, so we call that a minus 2. If I add that 2 to the right, we get 3, and divide by negative 3 makes negative 1. Again, at that point, we're just solving this equation. Combine any like terms. Again, move anything to the other side if we need to isolate that x value, and we've got part of our answer. Again, it's only part of our answer because, again, we need to identify a full coordinate, right? Our solution to a system is going to be a full xy coordinate. Well, let's take that negative 1 then, if I know what x is, and we can insert that right back up into this equation here. So notice I took y equals negative 2 minus 2x, so y equals negative 2 minus 2 times negative 1, right? Inserting x, doing a little more substitution. Negative 2 minus negative, or minus 2 times negative 1 becomes a plus 2. Negative 2 plus 2 would have been 0. And in that case, now our solution is negative 1, 0. And if we took that negative 1, 0, put it back into our original equations, that's checking our solution. We would quickly find out that, again, both sides equal 1 in the first equation, and both sides will come out to negative 2 in the second equation. Checking your answer is always a good idea once you found your solution. But the main idea is our overall answer is technically this coordinate, negative 1, 0. So let's try that one more time. Let's go to this next page. Let's try this example. Again, right now we're in standard form. We've got some nice looking equations, but I don't really want to be in standard form. I want one of my equations solved for one of my variables. So taking a look at this 6x and 4x and 2y, those might be a little bit more work, but this y right here in that first equation would be pretty easy to isolate. If we subtract 6x over to the right side, 37 minus 6x, is the same equation as that first equation, still equation number 1 there, but now I'm solved for y. In which case, we can go to that second equation, which would be 4x plus 2y, which I'm going to leave a blank there. I'm going to take out y again. I'm going to insert what it's equal to. So that's equal to 18. But now remember, instead of y, I'm going to put in this equation here, 37 minus 6x. Well, now it's our job just to clean that up a little bit. Again, that's 4x. 2 times 37 is going to be 74. And again, 2 times 6x would be a minus 12x. Doing a little distributing. Don't forget we're still equal to 18. We don't want to lose that equal sign. We can add some like terms. 4x minus 12x would be a negative 8x plus 74 equals 18. Let's subtract this 74 over to the other side. So again, we're going to be left with 8x, or negative 8x. Sorry, don't lose that negative. 18 minus 74 is going to be 56 to the negative. Right? 18 minus 74 would be a negative 56. Divide by negative 8 on both sides, and we get half of our answer again. Once we know what x is, again, we're going to take that right back up top and figure out what y is. Y equals 37 minus 6 times our x value of 7. So y equals 37 minus 42, and therefore y equals negative 5. I hope that helps you work with substitution. Again, the main idea, get one equation, solve for one variable, then plug that equation into the other equation, 4x plus 2 times y, only I knew what y was equal to. Y equaled 37 minus 6x. Remove the y, insert the equation, clean it all up, find your two variables. If you have any other questions, make sure you talk to your teacher. Otherwise, good luck and have fun.